This is sections 13.2 and 13.3 on the slope of a line. Slope is something you've learned in Algebra 1, I'm sure. Let's define it here, perhaps in a slightly different way. The slope of a line is primarily the ratio of two things. It's the ratio of the change in y to the change in x. So it's comparing how y is changing to how x is changing. It's normally expressed as a fraction, as we can express all ratios. So it is the ratio of the vertical change, because y is graphed vertically, to the horizontal change, because x is graphed horizontally. The slope is the ratio of the vertical change to the horizontal change. In that way, slope is a rate of change. It's a measure of how one variable changes with respect to another variable. If I change one variable, how is the other variable going to change? According to this set line, which is really a pattern. If we think of geometry as a study of patterns, that's really what we're doing here. We're studying the pattern by which the points of the line are arranged. If I change one variable in a certain amount, how much am I going to change the other variable according to the pattern? So it's really a measure of the line's steepness. How steep is it? So that's the way we're going to think about slope here. So to find the slope of a line, slope is the ratio of the change in y to the change in x. So the change in y is the difference in the y coordinates. So in my graph here, I've got 2 points, x1, y1, and x2, y2. The change in y is how much y is changing from x1, y1 to x2, y2. How much is y changing? Well, we subtract the y coordinates. y2 minus y1 will tell me how much is changing from y1 up to y2. The change in x is the difference in the x coordinates. How much is it changing if I go from x1 to x2? So I subtract x2 minus x1. And that's how I'm going to find the slope. Take the difference in the y coordinates over the difference in the x coordinates. The change in y over the change in x. It does not matter which 2 points on a line we pick to find the slope, because any 2 points on the same line will give us the same slope. So here's some examples. Let's find the slope of each segment. In the first one, I've got the point 5, 4 and the point 3, negative 1. So to find the slope, which we usually label with m, I'm going to take the change in y over the change in x. Change in y is the difference in the y coordinates. 4 minus negative 1. Change in x is the difference in the x coordinates. 5 minus 3. Simplifying that, 4 minus negative 1 is 4 plus 1, which is 5. 5 minus 3 is 2. So the slope is 5 over 2. I always need to simplify my answers, but that one is already simplified. Leave your answers as simplified fractions, not mixed numbers. On the second one, I've got the point negative 2, 5 and the point 7, 2. So my slope is going to be 2 minus 5 over 7 minus negative 2. 2 minus 5 is negative 3. And 7 minus negative 2 is 7 plus 2, which is 9. So I simplify, and I get negative 1/3. Now, I took the point 7, 2 here as my x2 and y2, and the point negative 2, 5 as my x1 and y1. What if I switch them? Doesn't matter the order in which I go. So let's try that. And let's take 5 minus 2 over negative 2 minus 7. switch the order in which we subtracted the y's and the order in which we subtracted the x's. Let's see if we get the same answer. 5 minus 2 is 3. Negative 2 minus 7 is negative 9. If I simplify that, I get negative 1/3. So it does not matter the order in which I use the points as long as I'm consistent. And the one that I used as y2, the x-coordinate of that has to be my x2. The one I used as y1, the x-coordinate of that has to be my x1. So I have to be consistent. Horizontal lines are lines that are, in a sense, perfectly from left to right. They're not angled at all. So let's find the slope. I'm going to take the difference in the y-coordinates, y2 minus y1, over the difference in the x-coordinates, x2 minus x1. But if this is a horizontal line, y2 and y1 are the same. They have the same y-coordinate. If I trace them back to the y-axis here, they hit at the same point. So really it's y2 minus y2 over x2 minus x1. The two y-coordinates are the same. The x-coordinates are clearly not. If I trace them down to the x-axis, they would hit at different points. But the y-coordinates are the same, which means the top is just 0. The bottom is some number that's not 0, but the top is 0, and 0 divided by anything is 0. So for any horizontal line, I have a slope of 0. Horizontal lines have a slope of 0. Always. What about vertical lines? Let's find the slope. I'm going to take y2 minus y1 over x2 minus x1. This time, because it's vertical, the x-coordinates are the same. So I have y2 minus y1 over x2 minus x2, which makes the bottom 0. What happens when I try to divide something by 0? It's not possible. It's undefined. So we say vertical lines have an undefined slope. It's not right to say it has no slope, because the word no is sort of a synonym of 0, and that's not what we mean here. Vertical lines don't have a slope of 0. It's just that the concept of slope does not apply to them. Our definition of slope does not apply to vertical lines. They are undefined. We cannot define it. A couple more examples. Find the slope of the line through the points given. So we don't have a graph, but we can still find the slope. M is going to be the difference in the y-coordinates, y2 minus y1, over the difference in the x-coordinates, x2 minus x1. So 2 minus 1 over 3 minus negative 4. 2 minus 1 is 1. 3 minus negative 4 is 3 plus 4, which is 7. So I get positive 1/7. Number 4, I take y2 minus y1 over x2 minus x1. So I've got 7 minus 7 over 5 minus negative 1. 7 minus 7 is 0. 5 minus negative 1 is 5 plus 1, or 6. 0 divided by 6 is 0. So my slope is 0, which means this is a horizontal line. Now what about parallel lines? Way back in the first semester, we defined parallel lines to be coplanar lines that never intersect. So they have to lie in the same plane, they have to be coplanar, and they never intersect. The lines are infinite, they go on forever, but even if we were able to draw them forever, they would never cross each other, they would never intersect. They would never have any points in common. Like the two lines that I've drawn here. If I claim that these two lines are parallel, which I could maybe denote by putting these arrows on them, what has to be true about their slopes? If they're never going to intersect, then they must be going the same direction constantly. They must always be going at the same angle. That's another way of saying that they must have the same slope. The slopes must be the same. If they're not, if one of them is even slightly different, then eventually they're going to intersect. So the slopes must be the same. And that is this theorem. Two non-vertical lines are parallel if and only if their slopes are equal. So it's a biconditional, because we have the words if and only if. It means we can go either direction with it. Two non-vertical lines are parallel if their slopes are equal. And if the slopes of two lines are equal, then the two lines are parallel. Why do we have to specify non-vertical? Because we're talking about the slopes of these lines, and if they're vertical, concept of slope doesn't apply, so we can't even talk about that. So we need to, in our theorem, understand that we're only applying this to non-vertical lines. But if we have two vertical lines, they both have an undefined slope, and they're both going to be parallel. We can also talk about perpendicular lines, lines that make a right angle. What has to be true about their slopes? They're definitely not equal, because if they were equal, they'd be parallel, but these intersect, so they can't be parallel. But two perpendicular lines, their slopes need to be specially related to each other, and this theorem tells us how. Two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So when we multiply the two slopes together, we should get -1. If we do, they're perpendicular. For example, if I have a line with a slope of 3/4 and a line with a slope of -4/3, when I multiply those two fractions, I get -12 over +12, which reduces to -1. So those two lines must have been perpendicular. A line with a slope of 3/4 and a line with a slope of -4/3. So what would have to be the slope of the line perpendicular to a line with a slope of -5/2? What do I need to multiply -5/2 by in order to get -1? Well, if I need to get a negative, then the number I'm multiplying by must be positive, because I already have the negative, so it needs to be positive. And if I want it to reduce properly, I need to put a 2 on the top, so it cancels with the 2 on the bottom of the first fraction, and put a 5 on the bottom, so it cancels with the 5 on the top of the first fraction. So the way that we get the slope of a perpendicular line is to flip it and make it the opposite sign. That means we're taking the reciprocal and taking the negative of it. So if it was negative, the negative of a negative is a positive. So we're changing the sign. So it's just as accurate to say two non-vertical lines are perpendicular if and only if their slopes are negative reciprocals. They're opposite signs, and flip one and you get the other. And here are your immediate practice problems. Number 1, find the slope of the line that's drawn, and you need to draw the picture on your paper and show me the work. And number 2, find the slope of the line through the points that are given there, 6, -3, and -1, -2. And you need to write the problem and show your work. And that is the end of sections 13.2 and 13.3.